film. That's the future. What do you know about Ariane 6?
I think that Ariane 6 will pursue the work initiated with Vega by transposing new technology proven previously. I think about composite fiber cases or the electrical nozzle actuator. You know, today, large solid boosters with composite casing are considered as the baseline for the booster, the first stage and the second stage of Ariane 6.
The links between the two launchers, between Vega and Ariane, are considerable. It's surprising. Without Ariane, you don't have Vega. Now, without Vega, you don't have Ariane 6.
Yeah, there is definitely a legacy.
Turning to the satellites, you can see exposed to the elements Proba-V. That's the silver box on the right. Underneath that, the black triangle is the Vespa, which will be separated afterward. Up next, a look at Proba and Vega with the Proba-V Satellite Mission Director, Karim Melab.
The Proba program was initiated in the 1990s with a clear determination of demonstrating new technologies in orbit. Within that framework, Proba-1 and Proba-2 were launched in 2000 and 2009 and have been orbiting to test these new technologies. Proba Vegetation is purely a Proba satellite in line with Proba-1 and 2. It's a technical demonstration platform with an operational observation mission, observation of the vegetation. Proba-1, Proba-2 and Proba-V, beyond that, we aim to continue that with a new satellite or two that will be called Proba-3, and which will have as a purpose the demonstration of formation flight. Vega was chosen because it's a highly agile launcher that can have these specific types of missions such as we will have tonight. Multiple launches, Proba-V, VN-RedSat, a demonstration of the re-entry of the last stage. This type of launcher is very interesting for us institutionally to test and embark very different types of satellites. Over the past 6 weeks, the work we carried out here was truly outstanding. The nature around us is very pleasant and has allowed us to work in very pleasant surroundings. And the installations allow us to work and relax and prepare the satellite for the launch. As soon as the launch has been performed, we will go to Redu in Belgium to track the satellite, and we have 6 months' work before us.
We spoke with Karim Melab last night. He told us a couple of interesting notes concerning Proba-V and the next ATV, which is called the Albert Einstein, as you know, that's scheduled for launch here in June and is currently in its preparation phase here, I should say. The first one, when Proba-V was transferred from one satellite building to another, from the S1 building, to be precise, to the S5, it rode in the same container built for the ATV. Yeah. And I don't know if you realize, but the ATV weighs 20 tons. Yeah. And Karim's satellite weighs 138 kilos. And he said as his team and he watched their small satellite absolutely dwarfed in this huge container, they, amid all that space, they were almost afraid it was going to get lost. You saw in the pictures in the launch campaign that we had, I don't know if you recall. The second thing was when Proba-V came to the same satellite preparation building, it came to the exact same spot where the ATV had been until 2 days previous. Oh, and the ATV moved to another room. So Karim said you had the ACE's biggest and smallest satellites at the same place, at the same time. Next, a film about Proba.
The European Space Agency, ESA, works at the forefront of new satellite technologies and scientific breakthrough. This is where Proba satellites come in, as an orbital test platform for new technology. Although ESA can simulate some parts of the extreme space environment here on Earth, it's not sufficient and can never replace the full conditions of space itself.
To make sure, or to give the confidence that that technology will actually work as advertised, you really need to be in orbit. And that's where the microsatellite that we use in the Proba series came up. They help us to get the final validation for our technology.
The Proba family is a set of small, simple, robust satellites using materials with proven reliability. Although they are relatively low cost and are the size of a washing machine with solar panels, the Proba satellites are packed with innovative instruments and offer a great testbed for research. Proba stands for Project for Onboard Autonomy, which means that these mini satellites are smart enough to manage themselves in space. ESA launched the first such satellite, Proba-1, in 2001. Its mission was to demonstrate a new type of environmental monitoring instrument, measure radiation along its orbital path, and test a new generation of batteries. It's actually still being used today for Earth observation, and this success has opened up new opportunities.
In the case of Proba-V, which gave the name to the series, it was the autonomy on orbit of the satellite itself. And then we send out an AO saying, we want to try this. This is the spacecraft on which we're going to do it. Who out there is interested to use it for a mission, for a scientific mission? So we have what we call a payload of opportunity.
The experience was repeated in 2009 with the Proba-2 satellite, and this time the success of the experimental payload was even greater. While in space, Proba-2 continuously monitors solar activity and space weather, sharing its data with solar scientists and meteorologists worldwide.
This is really the way to go, and this effectively achieves what we want. They gotta stay small, they gotta stay fast, and they gotta stay cheap, but at the same time, we need to do more innovation, more innovative missions in this sense.
And the innovation continues, as ESA is developing a pair of Proba-3 satellites demonstrating formation flying in space to study the Sun from 2017. And now ready for launch from Kourou aboard Vega is Proba-V, V for vegetation. This is the first time a Proba satellite has been assigned an operational mission from the start. It will monitor vegetation growth on Earth daily with a compact new imager. But being a proper prober, the new mission also carries with it some technological demonstration payloads, including an innovative system to track aircraft in flight around the world. Sometimes with small, you can think big.
You're watching Arianespace's second Vega launch with 3 satellites, Proba-V, Vinredsat-1, and S-Cube. Enrico, you were here during the campaign. What impressed you the most?
What impressed me the most? I think the great care that everybody had taken to limit as much as possible any contamination on Proba-V optical instruments. You know, their sensors are very sensitive.
It's an ESA mission dedicated to demonstration of innovative technologies, as was mentioned. I don't think anybody mentioned that the Proba satellites are ESA's smallest.
But it's true.
Smallest satellites, right. Small satellite, big missions. Proba-V was developed in Belgium. New instruments on board make it an improved version of its predecessors, they mentioned in the film, launched in 2001-2009. Our next film, another look at Proba vegetation. V for vegetation. We'll be back.
ESA's Proba family is soon to be extended with a 3rd satellite that will send into orbit Proba-V. V for vegetation. While earlier Proba satellites were in essence demonstrators for testing new innovative technologies, Proba-V will be the first Proba satellite assigned an operational mission from the start of its development. This new Earth observation satellite will deliver information continuously about the status of vegetation across our whole planet. And it also embarks experimental technology payloads.
That is one of the elements that promotes the Proba program, is to fly new technologies and to be precursor on certain number of domains before it goes to operational satellites or to demonstrate that this technology is valuable for the future.
For example, key technology payloads on board the Proba-V are a new reception system for air traffic communications and a new high-density fiber optic system. But vegetation is the absolute key to this Proba's mission. The vegetation payload has been flown aboard French Spot satellites since 1998. But as there was no room for it on new Spot satellites, ESA opted for a dedicated Proba platform. So Proba is now a small satellite with the vegetation instrument as a big payload. A major change for the industry, in particular for the Kinetic company.
The original vegetation payload is bigger than the whole spacecraft that you see behind me. What we needed to do is to miniaturize the payload so that it could fit on a Proba-like satellite. And with the new technologies that have been developed in the optics, we have actually been able to reduce the size and the mass of this payload to fit on the standard Proba platform.
Although the payload is smaller, its performance has actually improved. Thanks to instrument advancement, Proba-V will be able to cover a swathe over 2,000 kilometers of the Earth's surface at every pass, double the previous range. This enhanced payload will give scientists a daily overview of the global vegetation growth and will also guarantee the continuation of the existing vegetation dataset, thereby playing a key role in Earth observation.
Proba-V will give us an indication on the status of the vegetation, but also on the changes, and those changes can occur either within a year or also between the years. This will give us insight into the changes of the land cover and of the vegetation, and will help us to look at, for example, changes introduced by mankind, agriculture, forestry and usage of the land cover.
A small but smart satellite, Proba is a solid illustration of what space can bring. And with this vegetation mission, another technological achievement that will help us better understand our planet.
Turning to our second passenger, Vinredsat, the third satellite. It will be launched by Arianespace for the nation. Venasat 1 went up in April 2008 on Arianespace flight number 182, weighing 2.6 tons. And Venasat 2 launched in May of last year on flight 206, weighing nearly 3 tons. You can judge by the weight that both of those satellites could not be launched tonight on Vega. They were launched, of course, on the heavy, Ariane 5. Here's something I bet you didn't know. Vega was one of the names proposed in 1972 for what became Ariane. Did you know that?
No, I think I was too young.
Were you born at least?
Yes.
1972. Other names were Phoenix, Lyra, Cygnus, Ganymede, and Penelope.
Wow.
Up next, an interview with the satellite mission director for Vinredsat, Brigitte Tedaldi of Astrium.
In the framework of the Vinredsat-1 program, Astrium will give Vietnam and VAST, Academy of Science and Technology, its first system of Earth observation. It is an optical satellite which will be in heliosynchrone orbit at 680 kilometers. It is part of the range of the AS100 product that Astrium has developed in partnership with the CNES and has delivered for numerous satellites. Together with the satellite, Astrium has also provided all the ground segment, which allows to check the satellite, but also to acquire and to process the images. Astrium has also trained a team of 15 Vietnamese engineers who will become responsible for the operations of the system as a whole. Astrium, as a major industrialist, must find the best solutions to meet the needs of its clients. Today, Vega provides a wide range of satellites with a great variety of orbits. Vega allows multiple launches with the Vespa structure made by Astrium in Spain, and therefore Vega presents advantages since it allows optimized launch configurations. In Kourou, the Ariane 5 Soyuz range and now Vega will enable us, industrialists, to make proposals of optimized configuration launch. And for our commercial offer, this is a major asset since we are always looking for program possibilities.
Everything is okay on board as Vega is performing flawlessly. The fourth stage is flying. We're in a coasting phase right now. Enrico, you helped design the Vega launch pad. That was in an earlier job you had.
Yeah, the big deal was the mobile gantry. The principle is to have the same as for Ariane first. The mobile gantry is used to integrate and test the launch vehicle. You know, the mobile gantry is a tower tall about 50 meters and heavy 1,000 tons, quite a lot. Then it is moved away 100 meters back. Quite a challenge.